Hi everyone. In this two-part video series, we'll walk you through how to incorporate passwordless Keyri authentication, both in a mobile app and on a web app that are backed by a Firebase authentication system. By the end of this guide, your users will be able to register and log in with just a tap or scan backed by a smartphone biometric security sensor. This guide assumes that you have a mobile and web app that uses one of the authentication methods that Firebase offers out of the box. In this example, simple email/password authentication, as you can see here on the web app, and here in this example mobile app that we have set up. And in this guide, we'll show you how Keyri can operate either in parallel to the options Firebase provides or replace them entirely. In the second video in this series, Keyri's head of mobile engineering will walk you through how to incorporate Keyri passwordless capabilities into a Firebase-backed mobile app. In this example, iOS app, which you see on the right side of my screen here, which is a live view of my own device. In this video, though, I'm talking about how to build a web app that you see here using Keyri Auth and the simple server functions that enable Keyri functionality for both the web app and mobile app. Users can register or log in through Firebase's built-in email password method, such as here. We're just going to go ahead and register. And now it knows we're registered with a password. And they can log in by scanning the Keyri QR code you see here. And there you go. Now a user can register or log in rather through both email password and Keyri Auth. And it's the same display name and the same user ID. In both cases of login, you'll be accessing the same Firebase user profile so that you don't have to treat users differently depending on how they register or log in. And by the way, the source code for this entire app, including the mobile app, will be in GitHub repositories linked in the description. Let's get into it. First, we have to configure some things in Firebase. In the authentication suite, we have to enable anonymous sign-in provider. This is where Keyri only fully passwordless users will fit in, and they won't actually be fully anonymous. They will still have identifiers like emails, phone numbers, and UIDs, and you'll be able to add other authentication options to their profile like email password, which is the one example I'll show you in this guide. Other methods like Apple or Google OIDC are also available to be added to these technically anonymous users. You'll also need a database to store Keyri public key credentials. In practice, you can use any database you want, but in this simple example, we'll stick with Firestore. So just make sure that you have Firestore enabled. Now let's get into what your server will look like, and then we'll talk about the web client. Everything about the server we're setting up will be made clear once we get to the web client. So bear with us for just a second. Now here is our actual web client and server project. It's all in one directory. Ignore this separate server directory. That is if you want to deploy on, for example, a standalone Express server. But this directory here includes server-side functions, APIs, as well as the web app. It's a Next.js project that uses Next 13's awesome API routing and Vercel's serverless capabilities. So we don't strictly need a server just for Keyri functionality. The functions in this project can be deployed on any serverless platform or incorporated into your existing server. We just need to expose some simple functions via APIs. Now, let's keep all of our Keyri related functions in one file, and that's what we're looking at here. First, import Node's built-in crypto module, which is OpenSSL based, by the way, so everything crypto related in this guide can be applied to any server runtime. Next, you'll need to import Firebase admin, so you'll need to install this package via your package manager of choice. And just to be clear, these are all of the dependencies that we'll need in this project, and I can get to the ones that we have to manually install in due time. But for the most part, you can see that it's a pretty dependency light operation that we're running. Now we need to set up Firebase server-side admin configuration. And so you'll see here we're importing a configuration from another file. And I've chosen to put that file into a config folder. And effectively what it's doing is it's pulling values. It's creating a JSON that's pulling values from the runtime environment. And these environment variables are stored in an env file. Now, when talking about Firebase, there's Firebase client and Firebase admin. So admin is effectively what runs on server side, and client is obviously what runs on web and mobile apps. And there are two different sets of credentials. So in case you're unclear on how to get Firebase admin credentials, I'll just show you really quickly here. Go to your project overview, into settings, into project settings, go to service accounts. And here, if you click generate new private key, it'll give you a JSON that contains basically all of these values. And now, obviously, you don't want to just have this JSON lying around in your project directory. You will need to, well, in terms of best practices at least, you'll need to break them out into their own environment variable and then later import them into a file and assemble that JSON and then later export that JSON. That's just a best practice. Coming back to the main Keyri Firebase functions file, just import that configuration and use it to initialize the Firebase admin app using this sort of function. Then enable Firestore by, of course, first importing Firestore from the Firebase admin package, and it's as simple as assigning that to the DB constant. Getting into the heart of things, let's first make the Keyri register function. So this takes in a user's email and public key. The public key and email, for that matter, come from the mobile app only, and this entire function is exposed via an open API. So before we get to the API part, let's just talk about this function. First, check if this user by this email already has a Firebase authentication profile. If they do, then create a Firestore document for this user named after their email address within a collection that we're calling users, and stick in there the user's public key along with their UID and email. One quirk of this implementation is that whenever Keyri register is hit, an existing user's public key will be updated to whatever was most recently provided. Now, in practice, you'll want to, for example, not allow this updating or require some other sort of authorization to update the public key, because this rather simple implementation has the potential to lock people out of Keyri authentication. They'll still be able to access password-based and other sorts of Firebase login methods, but the key part is to store the user's public key within their own document within the user's collection. In any case, now use the existing user's UID in Firebase admin's auth create custom token function and return that custom token so that when the user registers, they can also get logged in on their client. If a user with the input email address doesn't exist, then first create a profile for the user in Firebase authentication. And then you would just do what we already did, which is create a database record for that user, store their public key and their UID, and return a custom token to whoever had posted to this function. Now for some simple cryptography fun with Keyri login used to authenticate existing users. We'll make a helper function for the cryptography called verify signature. which, as the name implies, verifies a cryptographic signature of a piece of data that the mobile app sends over along with the user's public key. So first, you'll just want to make sure that all of the data that the function needs is in fact present. Now, the data that you're getting is actually a Unix timestamp concatenated with a nonce with an underscore in between. So data is timestamp underscore nonce. And so we're defining the timestamp by slicing out the timestamp part of the data that was passed in. We need to first verify that the timestamp is, in fact, a timestamp. And we also need to make sure that the timestamp was generated relatively recently. That is to say, the mobile app recently generated this authentication request. And so in this case, we're just trying to make sure that this authentication request was created and sent within the last 60 seconds. And so if either of those checks fail, then the signature ought not be valid, and basically the individual should not be authenticated. This part here that makes sure that the timestamp is recent prevents replay attacks. Now for some cryptography 101. Let's verify the signature given the data, public key, and signature. And in the process dealing with some minor node-specific quirks. First, make the public key into a full PEM key by adding the header and footer. That's this and this. Now set up the crypto.verify data stream and add to that the data that you received. And you have to convert that data into a buffer, a byte array, and then kill the verify stream. Next, you actually run the verify method on the verify stream that you just ended by passing in the user's public key as well as the signature. And the signature as well, you have to convert to a byte array with this buffer.from method. And so if this verification is valid, it'll just return a Boolean. Well, either way, it'll return a Boolean. It'll return either true or false. And the point of this entire function is to use this true or false to determine whether to authenticate the user. And so that's why we're using this entire verify signature function within the actual Keyri login function. And this is the function that'll actually get exported out to APIs. The actual Keyri login function wraps this verify signature function, and it's the function that will be actually posted to via a public API. It requires a user's email, the aforementioned data, and the user's signature, again, generated by the phone. So these two are generated by the phone. This is sent by the phone. We're using this email to basically look up the user's public key from Firestore. So again, we're looking in the user's collection, we're getting the user specific doc, and effectively just pulling out the public key from that user doc. Once we have that public key, we have everything we need to actually verify the signature. And so we pass in the public key, we pass in the data, we pass in the signature. And then if verified is true, then go ahead and run the admin auth function for getting a user's record based on their email. And once you have the user's record, you can pull in their UID. And using that UID, you can run the create custom token method on admin auth. And you'll be ultimately returning this string, this custom token string. Finally, let's just export these two functions, Keyri register and Keyri login. Now that we're exporting these critical functions, let's expose them via API. We'll start with the Keyri login API. And the way that Next works is basically you have this API folder within the pages folder, and everything within the root of this API folder. As you can see here, there are these two, Keyri login and Keyri registration, are each their own API endpoint. So Keyri login is one of those endpoints that we're creating. Now, to allow this API to be hit directly from our mobile app, or for example from Postman, basically outside of our web application, we need to use CORS. So you need to install the CORS package with your chosen package manager. And then, of course, we need to import the Keyri login function from this kind of master functions list that we've created here. Next, configure CORS. And this is a bit of a quirk of the Next.js API routing mechanism. It's effectively a middleware that ultimately allows us to pass in our CORS preferences. And it's fairly simple. You can just kind of copy paste this. The actual API is defined by the handler function. This part is boilerplate. So the very first thing we need to do is initiate this middleware that we just created up above. And then next, of course, because we're running the Keyri login function, we need the user's email, data from the phone, and a signature generated by the phone. Again, just verify that all of the data is present, otherwise send an error. Otherwise, run Keyri login and get the custom token. And finally, send that token to whoever is requesting it. That's Keyri login in a nutshell. The Keyri registration API is very similar. Again, we'll need to import CORS and configure CORS. We'll also need to import, this time, the Keyri register function and effectively copy paste this this middleware function from what we did here before. It's the exact same. And here again we have an API handler, and again within this handler the very first thing we do is run this CORS middleware. In this case, because we're running the Keyri register function, the only things that we expect are email and the user's public key. And again, if those are missing, just send a 400 error. If all is good with the body, then try and run that with the actual Keyri register function. And if it all succeeds, then you should receive a custom Firebase token, just as you would with the Keyri login API. And finally, send that token to whoever requested it. And that's it for the server-side operations you have to deal with. We've set up the required functions and exposed the API endpoints. The API part of this process may be harder if you're using something other than Next.js's API routing functionality, but if you already have a server set up, it'll be at least as easy as this, because you may or may not have to configure these CORS items and deal with the Next.js peculiarities as they relate to CORS. Finally, moving on to the web client, we basically have this entire application in one file here in index.js, and it is just under 300 lines of code. This is a super simple Next/React single page application, and we're not doing anything fancy like breaking out and importing components, passing around props, or anything like that. The entire web app is contained in these few lines of code, and a lot of that is for the standard authentication stuff that you would need to implement anyway, as well as some state handling and conditionally rendering some text depending on what type of user is logged in. So first, within the web app, let's deal with the imports. The head component is a default component provided by Next.js. It'll come in handy for things like SEO and defining the title of your web app and things like that. You'll also need styles, and again, Next.js is great because you can have scoped modular CSS files. That's what we're doing here. We'll also need useEffect and useState hooks. And now we also need to install the Firebase client SDK. and that is separate from the Firebase admin SDK. So again, install Firebase client from your desired package manager. And we'll need to import from the core of that package just the initialize app function. Beyond that, rather, from the auth section of that package, we'll need get auth. So the standard parts are get auth and sign in with email and password, create user with email and password, and sign out. The somewhat unique things that are required to have Keyri run are sign in with custom token, email auth provider, and link with credential. And finally, we'll need to import get Firestore doc and get doc from the Firestore section of the Firebase client SDK. Now, the Firebase client SDK has to be initialized and configured very similarly to how the admin Firestore SDK was initialized, except these are a totally separate set of credentials, and I'll just show you quickly how to grab those. So here, project overview, go into the settings of your web app, and down here you'll find all of the values that you need. And once again, you really should put these into environment variables and pull them in during runtime. Now that we have Firebase client configuration defined, we need to initialize app and define app using that configuration. Then we need to initialize Firebase authentication with getAuth, passing in the same app definition. And likewise, we need to initialize Firestore with this app definition. Just below that, we have the actual home component. And the first thing you'll see here is a whole bunch of states. The first is the user state, and this user state is rather conveniently handled by Firebase. Basically, whenever the logged in state of a user changes, as in whether a user is logged in or logged out, this changes and user is redefined, set to null or something if someone is actually logged in. Next, we have the email and password states. These are just helpers for forms. Next, we have auth error and loading. So auth error is just there to conditionally render some text in case there is an auth error, specifically for the traditional Firebase auth component. So, for example, this individual has already registered, and so if we hit register, we'll get the sort of error thanks to the auth error state. Loading and set loading are there mostly for the Keyri QR login part of things, because we just want people to know that after they have scanned the QR code and accepted within the mobile app, that the QR login process is indeed happening, because it can take up to 1 full second to actually log in. Finally, we have these 3 states: Keyri user, password user, and unified user. And these are what I call kind of user types. So basically, a Keyri user is a user that has registered via Keyri credentials and does not have a password, and so is therefore fully passwordless. A password user is kind of the opposite. They are a user that has only registered via username password and can only log in that way. A unified user is a user who can log in through either method. And we'll get to how exactly we manage those in just a moment. Moving on, we will need 2 use effects. The first is there to listen to the Firebase authentication state, meaning whether there's a logged in user or not. Firebase auth sets up a listener and updates the presence of a user automatically, so this is pretty easy. When the auth state changes, we trigger 2 functions. First, we set the user to whatever user that Firebase auth has given us, and so that's That's this user state right here that's used quite a bit in this app. And then we run this function called define user type, and again passing in this user object. And as we'll see later, this function is used effectively to determine what the values of these three states are. The next use effect is there to listen to events emitted by the Keyri QR widget. Now, before we get to that in detail, let's just add the Keyri widget to our project. This is pretty dead easy. So in our public directory, just create a file called keyriqr.html. From Keyri's browser documentation, you can go ahead and grab the actual source code for this file, copy, and I already have it here, but paste and save. And that's it for bringing in keyriqr.html. We will later serve this as an iframe, and that's pretty much the extent of adding the Keyri QR code to your web app here that handles all sorts of JavaScript and styling. Back to the Keyri use effect. So we add an event listener that listens for events emitted by the Keyri widget. The correct event will have the Keyri attribute, will include some data, and its origin will be the page itself. This last one prevents this listener from being activated by things like browser extensions. Now destructure this event, and if there's no error in that event, define the payload as the data within the event. And subsequently activate the handle QR login function, passing in this payload, and we will get to the rather exciting handle QR function in just a moment. And of course, if there's an error, then we should set an auth error. Let's now set up functions for the vanilla Firebase email password registration and login features. These utilize the email and password form states that we've set up above. All you really need to do is pass in the auth object that you initialize near the top, the input email state, and the input password state into the Firebase create user with email and password method for registration, and for login, sign in with email and password. Once either of these go through, reset the email and password form states, and for error handling, set the auth error state to the message that you want to convey. With that boring stuff out of the way, let's get into the handle QR function that we're calling in our second use effect hook above. We're passing in the payload that the use effect defines, then first setting the loading hook to true so that people know that stuff is happening in the background while the QR payload is being processed and Firebase is being called and databases are being looked up. The heart of this function is getting the custom token from the Keyri login API we set up earlier. So to do that, we'll just do a post using the fetch API to the endpoint that we set up earlier. And in return, we'll get the string for the custom token. We'll use that custom token in a login custom token function, which we've defined just below here. And once we do receive the custom token, just set loading to false. Now, the login custom token function is just a wrapper for Firebase's sign in with custom token method that we imported at the top, just with more usable error handling. Our function just takes in the custom token, and the Firebase sign in with custom token method needs that token and the auth object that we initialized earlier. And in general, this flow authenticates the user and sets the user's state, just like the vanilla login email password and register email password functions would if you were simply using Firebase email password auth or some sort of OIDC flow. Here we have a UX related function called define user type that you'll recall what we're calling in our first use effect that gets triggered each time the auth state changes. The goal of this function is to determine, when a given logged in user is a Keyri only user, an email password only user, or a unified user that can use both. So first we need to look at the user's Firestore record to see if they have a Keyri public key. We'll define the docref as looking in the user's collection for that specific user's document. DocSnap actually uses getDoc to pull that document. Now, when this function is called, we need to first see if the logged in user even has a Firestore record. If they do, try to retrieve their public key. Then we have an if-then chain that defines the user type state. If they have a public key and the length of the user's provider data array is not equal to 0, as in it's greater than 0, then that means that they can use both Keyri and email password to log in. Now, just for reference, the provider data array is a property of the Firebase user object that contains the various ways that the user can log in. It would be empty if they can't log in via password or Google OIDC, Apple OIDC, etc. And if they don't have a public key, but they do have something in their provider data array, then they can only log in via password. And finally, if they have a public key and their provider data is empty, then that means they are a Keyri user. And so every single time the authentication state changes and there's a new user within the web app, we define the user type, and that user type is then used to conditionally render the text that we show in the logged in view. Next is the regular logout function that wraps the Firebase signout method. And aside from that, it just kind of resets all of the other states. Last, we have a function called add password to user. This becomes useful when a Keyri user is logged in, but they don't have a password, or rather they want the ability to sign in with a password, thereby becoming what we're calling a unified user. It's already trivial to add Keyri auth capabilities to a password user in the mobile app, which is simply adding a Firestore record containing their public key, but it's a little bit more complicated in the web app. This is where we use the email auth provider constructor and pass in the logged in user's email address and the password they want to add to their account, and defining the resulting object as a credential. Then we activate link with credential that, again, we imported earlier. And into that, we pass in the currently authenticated user and the newly created password-based credential. And finally, we run this define user type function, and this will inevitably output that the user is in fact a unified user. And that's basically it for the web app logic. Aside from that, we have the actual rendering part of the page. So we're 95% of the way there. This page is rendered conditionally based on whether there's a logged in user or not, and what type of user they are. So first we have the built-in head component, and we're just defining the title of the application and giving some metadata about it and defining where the favicon is. We're importing the styles, and here we're setting up some text that will always be there regardless of the condition of the logged in state. Those are just descriptions of what this project is about. Now here's where it gets conditional. So if there is a logged in user, then based on what kind of user they are, we render different things. If they're a unified user, we just congratulate them. They can log in however they'd like, but really they probably shouldn't use the password method just for the sake of security and for user experience. If they're a Keyri user, again, we congratulate them because they're set up with the awesome Keyri passwordless authentication flow. However, we also provide them the ability to add a password to their account if they want. And so here we just have an input box for a password, and below that we have a button that calls the add password to user function that we defined up above. Lastly, if they're a sad password user, we congratulate them. They've at least registered. But we ask them to enable Keyri by going into the Keyri app and simply logging in with the same email and password, and tapping register or enable Keyri. Regardless of what type of user they are, we will always show them their display name. In this case, we're kind of cheating and just saying that their display name is in fact their email, which it often is. And we're showing them their UID. Now, these are pretty important to show in this demonstration because a unified user should be able to see the same values whether they log in with Keyri or email password, thereby proving that they are in fact accessing the same user profile. Now, if they're not logged in, we give them two parallel boxes to log in or register. One is for the traditional Firebase email/password method, and the other is for the much nicer and more secure Keyri QR login functionality. For the email password box, it's just a form with two buttons, well, two form input fields, one for email, one for password, one button for activating the login function, the Firebase login function, and another button for activating the Firebase register function. And just below that, we conditionally render auth error. For the Keyri QR widget box here on the right, all we have to do is embed an iframe pointing to the KeyriQR.html file that we saved earlier in our public directory. Now, there's the source pointing to where it would be in our built project directory. So it wouldn't be under a public folder. It would just be there in the root. And of course, that can be changed however you'd like. And there's the sizing. You can make the sizing whatever you want, but this sizing seems to work well for readability and overall UI. You definitely want to set scrolling to no because it looks odd otherwise. You don't really need a frame border, but you do want to define a style in which the border is about 2 pixels, and I recommend that the border be white in case you have a dark background like this. And finally, the iframe should be centered within its parent div. And just below that, we have the conditionally loaded loading state or loading message. So if loading is true, then just say loading down there. And that's it. So we covered quite a bit more than just the parts required to incorporate Keyri QR and passwordless authentication into your system. But I think it's important to have everything contextualized in a so-called, mock real web app. Very importantly, we've also set up the entire backend required to support not only this web app, but also your mobile app. And for future reference, all of this information is covered in our documentation that's also linked in the description, as is the source code for this project. Please be sure to watch the next video in this series by our head of mobile engineering to see how Keyri passwordless authentication works in a mobile app and interacts with Firebase, or rather the Firebase APIs that we've set up, as well as the Firebase client that's used in that app for conventional username password registration and login. And that's it. Thanks so much for watching, and please stay tuned.